Also request Dr. Sardar Mohazzam, a key partner in this session together with us. Dr. Sardar Mohazzam, Mr. Raziuddin, Mr. Abbas Rajabi, Professor Safavi, So here's a vehicle with a registration number of AME368, white Honda City. ये जिसकी गाड़ी है प्लीज इसको मूव कर दें क्योंकि दिक्कत आ रही है. The registration number is AME368. Please move your car from the parking slot.
Assalamu alaikum, ladies and gentlemen, and a very warm welcome to all of our guests, especially the young out there. As we navigate one of our most defining energy transitions of our time, the ECO region finds itself at a strategic crossroads where to balance energy security, environmental sustainability, and economic resilience. And we will talk about all of these themes with our distinguished panel here, but basically on three vital levels. One is energy efficiency, second, electric vehicle as regional mobility, and then energy trade between our regional countries. So first of all, I'd like to introduce my very dear friend and a very distinguished energy researcher and policy practitioner, Dr. Sardar. He has been the managing director of National Energy Efficiency and Conservation Authority, the one-stop shop of energy efficiency and conservation in Pakistan. He has worked with UNDP, UNFCCC. He has led the MIT Climate Collab on energy water nexus. A lot of work he has done, and I have learned from him. With Dr. Sardar, we have Mr. Raziuddin. He's been a mentor. His knowledge of energy, upstream, downstream, within oil and gas sector is really remarkable. He's been the chief executive officer of for oil and gas company limited, and the chairman and CEO of FX Energy Limited. So we'll hear from his resume as well. Then we have Professor Abbas Rajabi, head of the Sharif Energy Research Institute from Iran. We will talk about during his 15 years of professional career, he has participated in numerous national conferences, and within that sphere, we will share his wisdom with us as well. We have Professor Sayyid Ali Akbar Safavi, he's Professor of Systems and Control Engineering in Shiraz University, Iran. He has an MSc degree in Control Engineering from the University of from NSW, Australia, and a PhD in Process Systems Engineering. And he has been for many years directing board members of various scientific associations, including artificial intelligence, system identification, his basic thematic areas. And then we have a very dear friend of Mr. Khalil Razai, the programs manager for energy and climate in ECO Science Foundation. I have personally learned from him from his electric vehicle mobility work across the ECO region. So let's hear from our panel, starting from Dr. Sardar.
Or Assalamualaikum. Assalamualaikum and very good morning, afternoon, maybe to all of you. It's my distinct honor to address this esteemed gathering. At the outset, I would like to extend my sincere gratitude to ECO Foundation and host partners for organizing this important strategic planning session. I think this is very timely to discuss collective vision for a more future sustainable and resilient energy future for the ECO region. The energy landscape across our region is shifting rapidly, and rising energy demand, climate change pressure, and global movement towards decarbonizing are reshaping how we produce, consume, and manage our energy resources. Against this backdrop, energy efficiency is no longer a choice, it's a strategic imperative. It is the fastest, cheapest, and cleanest route to achieving multiple objectives, ensuring energy security, reducing greenhouse gas emissions, improving the economic competitiveness, and enhancing energy access. It's worth mentioning that ECO region holds some of the world's largest untapped oil and gas reserves, encompassing more than 540 million inhabitants and spanning over 8 million square kilometers. The region holds about 30% of the world total energy reserves, with Kazakhstan accounting for 95% of the regional oil reserves and Turkmenistan holding 83% of the regional gas reserves. And when we look at some of these countries on the other side, which are starving for energy resources, Pakistan is one of these countries which spends somewhere around 15 billion US dollars annually on energy imports. So this much energy demand, and at the same time there is ample supplies available in the region. How we can collectively develop the system? And I think this is also proven through the studies that the 20% of the energy in the region is wasted due to outdated infrastructure, inefficient appliances, and lack of conservation practices. This not only strains our resources but also exhausts energy insecurity. Energy efficiency is the most immediate and cost effective solution by optimizing energy use. I think we can definitely improve our energy intensity, reduce our energy imports. I would just like to highlight a bit on some of these work currently being done in Pakistan. And I think this is important to inform the audience and also to develop this consensus among different countries, especially those who are starving for energy resources or have limited energy resources, that energy efficiency or whatever is available energy resources, how we can efficiently use them in our businesses, in our industry, in our other practices. And similarly, I think the countries who have abundance of energy resources, they have another challenge that we are foreseeing in terms of climate change. The CO2 emissions and the global warming that we are facing. And one of the examples is recently in Islamabad, the hailstorm that you have just seen, I think indicates like how we should look into this whole area. And I think this is where we see that the countries who have ample resources of energy, how the future trades, how the future demand and the production should reshape, and we should revise it. I would highlight today, I want to just make, especially because the topic is focused on some of the areas where mobility is being highlighted, and also along with that, some of these other work regarding how much in the policy perspective that government of Pakistan has put in place. We can see that in National Energy Efficiency and Conservation Policy, the threat target for 2030 is 9 million tons of CO2 to million tons of oil equivalent savings, energy savings, and that will be equivalent to 35 million tons of CO2 emission reductions. I think, especially to address and to achieve these targets, we have currently rolled out energy conservation building code, and I think that is one of the key areas where we are currently working. Regulatory framework for electric vehicle charging infrastructure and battery swapping station, and similarly, a very comprehensive awareness campaign in multi-stakeholders engagement. I must say that these areas which we are just saying, I think one of the classic example in Pakistan, even where we have shortage of energy and we see one of these challenges where we are relying more on imports. Even in case of electricity demand in winters, and especially last couple of months, you see electricity demand was not more than 10,000 or 8,000 megawatts. And in summer, we reach to 27, 28,000 megawatts demand. And this demand is purely when we're talking about from the summer, winter to summer movement comes from our air conditioning or fans, this whole cooling. So the question mark is like if we have our appliances efficient, if our buildings are designed in energy efficient way, this whole demand can be reduced to a greater extent. So the import bill for which we are paying 15 billion US dollars can definitely be addressed without doing major interventions into the system. I think similarly, the work especially on the EV infrastructure that we have the policies in place, but the proper take up of the people are not shifting. One of the reasons was lack of the charging infrastructure. So recently, the work is completed, and currently we are encouraging and supporting all the people, either students, entrepreneurs, businessmen, all of them, if they should come in, invest, and with a very low payback period, less than 3 to 4 years, they can get their investment back. I think it's a very good framework that can be availed by all and experimented in this area with how can the battery swapping stations or charging infrastructure can be developed in the country. Some of the areas, I think, the regional activities for the shared future, I think, I must highlight that the NEECA strongly advocates for creation of regional energy efficiency framework under ECOSF umbrella. And some of these initiatives, which I think should be addressed, such as joint energy audits that we can conduct for the buildings, for industry, and for some other areas. Similarly, harmonized standards. I think one of the reasons that can our products move from one country to another. What are the standards? I think, especially in ECO region, how we can set up our standards and move our products. And human resource is one of the major challenges that we face. That our human resource is not trained for energy efficiency and related activities. So I think capacity building of the human resource is one of the key areas which we should establish. Another area which I think, given the abundance of energy resources with some of the countries and on the same side, some of these facing challenges, and then the European countries are looking forward to establish a CBAM, that cross-border adjustment mechanism for the carbon. So this whole thing required that we should also develop some sort of sustainable financing mechanism in the country, in the region, and I think ECO region will definitely be a strategic uh, framework available for us to look into that direction. The knowledge exchange platforms and investment in innovation and institutional strengthening. This also plays important role like how we develop our institutions, strengthen them, and then they should provide basis that how we can collaborate together and develop this whole system around that. I think Pakistan acknowledges that every ECO member brings unique strengths, innovation, and lessons to the table as well. So we are equally open and eager to learn from the experience of our regional partners, especially in areas such as advanced grid systems, green financing models, and green technology development. By fostering a spirit of mutual respect and shared learning, we can build a stronger, more resilient ECO region. Let us work together to build an energy future that is not only sustainable and secure, but also shared and inclusive. A future where energy becomes a bridge for cooperation, not a barrier. Thank you very much.
Now to Mr. Razif for his few words. And just as a starter for Mr. Razif, as someone who has worked on both the upstream, downstream, across the energy value chain, and also on policy fronts, my first thing would be to ask, why has regional energy trading much more been a topic of conference rather than a real trade channel?
That's what that's it. Bismillahirrahmanirrahim. Assalamu alaikum, distinguished panelists, distinguished delegates, ladies and gentlemen, assalamu alaikum. We are not able to work on energy trade, but it's never too late. With the new scenario, I think oil, gas, and electricity is the best conduit for trade and progress. Trading sugar, textile, that takes different mode, but once you have a connectivity of pipelines, oil pipelines, and transmission lines, that's a permanent connectivity. And that's where these countries can work together and progress. For centuries, these countries have been trading, but in trading a different commodity. Now the commodity primarily is energy. So if we start trading energy, other things will keep on following. Our previous efforts, as we were discussing, this corridor of ECO has really failed compared to other organizations and other regional organizations where they have flourished. If you take the Far East, you take this South America, you take Africa, you take, of course, United States and Canada and Mexico, they have flourished. So we need to go and really find solutions that first why we have not been able to cooperate, and then now with this changed world, we need to cooperate by default. As I said, that gas can play a major role. Our Turkmenistan, Iran, they have tremendous amount of gas, 600, 800 trillion cubic feet of gas. So if that starts trading, and then Pakistan offers a great sea ports for exit of LNG and gas to the world, that can benefit all the countries north of us. And Pakistan having Indus River can be a fantastic riverine transportation. There have been plans for Trans-Afghan Railway, which has seen the paperwork but not seen anything in reality. So all these things that we have been discussing for the last decades, after decades, needs to be realized now for the progress and prosperity of the population of these 10 countries. Regional grid has been discussed a number of times. So many studies have been done by various World Bank, ADB, IDB, but nothing has really materialized. But I think the reason is that we discuss it and then we forget for the next 2-3 years. The best thing is way forward that we need to keep on discussing these things and meet every quarter or something to tell our governments that we are lacking, we are behind, and professionals have to send a message to the country, to the government, that we need to work together and come up with concrete physical projects of success. Expertise in the countries are there. 10 countries have massive amount of expertise we have seen in health and other sectors. So is also in energy. NEECA provides a fantastic platform for other countries to learn about renewables. At one time, Pakistan was almost very high on pedestal on CNG. That could have been a model for other countries. Similarly, we can learn from other countries. Electricity is one major requirement of the future. Electric vehicles, everything is going electrical, so we need to have these transmission lines where the generation will be, where the consumers will be, what is the population, what is the demographic. So this, of course, have to study and to make a very optimal and financially viable program. Way forward, from the energy point of view, I believe, is that there has to be a certain, there has to be a forum, there has to be a committee that is accountable, that is responsible to come up with plans, policies, physical projects, execution, and so on and so forth, to help all the 10 governments realize the benefits of being neighbors. Benefits of one country having too much gas, and these countries, what will they do with this gas after 50 years? There will be so many other options coming up. So this 600, 800 trillion cubic feet of gas needs to be utilized in the next 40 years on a very fast track basis, so that whatever Allah Ta'ala has given benefits to these countries have to be utilized and realized for the benefit of the population. The other thing is that expert working groups needs to be there. List of energy projects. We talk about Iran-Pakistan pipeline. We talk about Turkmenistan, Afghanistan, Pakistan pipeline, then you forget about it. Then we talk about the transmission line, and then you forget about it. So we are good at forgetting things, but I think that has to change now. We have to really come up with practical solutions. Financing, we need to have ECO bank. Of course, there is ADB and there's IDB, World Bank, but we need to have our own bank here. As neighbors, we need to flourish. Otherwise, this region will be left behind compared to other regions which are cooperating. And of course, there are always difficulties and anomalies, but table talk and continuous discussion is a good mechanism to come and resolve the issues. With this, I know the time is less and the Juma praise is come, and I thank you very much for patience listening. Thank you, Sardar.
Now the floor is handed to Professor Abbas Reddy. Professor Reddy, you've been directly involved in shaping the Iran Energy Master Plan and the Iran-Pakistan Electricity Interconnection.
Yes.
So with that, there are many lessons for us to learn.
Thank you, sir. Can you share my PowerPoint, please? Okay. It's like this. Okay. Bismillahir Rahmanir Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Good day, ladies and gentlemen. Before starting my talk, let me express my heartiest salutations to Dr. Taghibi and all his colleagues for excellent planning of this event. My talk will focus on renewables as a way to foster multilateral collaboration, as I faced a problem that raised and reiterated yesterday that caused weak interconnection and with collaboration between ECO members. At Sharif University of Technology, we have prepared offshore campus in Kish Island for international collaborations, and hopefully we have established a good record of collaboration, especially with ECO countries. This red zone shows ECO, the territory of ECO countries. And we see two figures, 550, 670. 550 is the actual population of 10 member countries in 2024. And 670 million is the projected population for 2035. So it means that in about a decade, we're going to host a population which is 3 times the population of Canada, or so close to the population of Japan or even Russia. That is enormous. We will host a country, a big country in our countries. Regarding the energy demand, excuse me for my voice, total primary energy consumption is expected. These are all the best available projections. Is expected to increase from 520 million tons of oil equivalent to 1,000 million tons of oil equivalent in 2035. So in 10 years, we should supply an extra energy demands, which is equal or approximately equal to the demand of Indonesia or Brazil. That is enormous. We will have about 20% increase in the population and 45% increase and 30% increase in the energy demands. That means increase in the welfare of the ECO members. But we should think about how much this gap should be fulfilled. Actually, we have problems in supplying energy in most of ECO countries, and the conditions will be worsened. Other factors should also be considered, like climate change impact on increasing cooling demand or affecting hydroelectric productions, for example, in Central Asia, or electrification of public transport. That also add to this imbalance. By now, during the 60 years of establishment of ECO countries, we, the member states, have learned to act independently without considering our neighbors. Each country, we have very limited records of knowledge and expertise sharing between the countries. Each country has developed its own energy plan, and we are normally relied on fossil fuels. Unfortunately, we have many sad stories of failure in multilateral collaboration. For example, Iran-Turkey gas pipeline was not successful, and it's not expected that the contract will be extended. Now we talking about terminating the contract. About 20 years ago, I have been engaged in a project between Ministry of Energy in Iran and WAPTA in Pakistan for an interconnection between Pakistan and Kuwait. That was not happening. Another interconnection between Tajikistan, Afghanistan, and Iran was not happening. The peace pipeline between Iran, Pakistan, and India that not happening. So we have not only we don't have a good record of collaboration, we have good record of failures. Energy crisis in the ECO member states will be accelerated by the problem in our infrastructure that should be renewed. I don't have any exact data about the decision each member state has already taken. I don't have access to the energy master plan of ECO energy ECO member countries, unfortunately. But it's expected that all countries have shifted to our renewables as a mean to rapidly respond to energy deficit. Turkey so far has well invested and well developed the whole supply chain for the renewables and PV solar electricity. Renewables provide a plausible and possible way for us to reconstruct or start a good collaboration between member states. The supply chain of a PV, a solar power plant or a PV farm has multiple components such as basic materials, concrete, structures, till PV panels. And each member countries have a part of this supply chain. So this provides a way to make a synergy between us. Also, we can share our resource and facilities in engineering and in construction for renewables. Transportation is a big issue in renewable energy technologies, especially PV and wind electricity. PV panels should handle with care, and that cause problem in transportation. And the countries normally prefer to import wafers and then convert them to the panels locally to reduce the cost and problem. However, I want to make an alarm that this is not the end of the game. Renewables makes us independent of fossil fuel, but not independent of science and knowledge. It is very dangerous to start massive renewable projects without have massive knowledge and expertise. That is like diving in a pool full of tar, and that will cause countrywide power blackout and failure in the power systems. The cooperation, the regional cooperation for renewables is a must rather than option. I try to explain why this is a must shortly and put the other explanation for the Q&A section. We are used to use thermal power plants with all of controls and manipulation we can make. However, renewable power plants, in particular solar and wind farm, are like violins. And the sound and the melody that a violin produces depends on who is playing the violin. If it's not played well, it will cause headache. But if you have the opportunity to be the audience of Ustad Rais, it would be other thing. These technical violins should be handled with care, should be good predicted and good controlled. Otherwise, we face problems. Climate issues like heat waves, like humid or monsoon waves, or like dust storms, which are increasing day to day in the ECO region, can also affect the operation of renewable generations. So, even in the European standard, body of standardization, they are now talking about energy yield laboratory, which measures the actual performance of the PV systems in each climate. So we should handle renewables with too much care than the conventional fossil fuel generation. I think, stop. Okay. I think cooperation on renewable is a sound and concrete project to overcome or on minimum alleviate the problem that we have talked on during yesterday panels. Renewables and collaboration on renewables help us to build collaboration on STI, science, technology, and innovation. It can help us change the fact that raised by Dr. Majid Khan, that we little know about our region. It can help us to increase the mutual trade from the actual level of 8%. It can help us preventing recycling the problem, as said by a respected panelist on yesterday, and help us to educate our students to mobile globally while help locally, as raised by Professor Akif, and design and implement education and vocational platform for all ECO members. Next slide, please. I believe that STI is an avant-garde and is a line breaker for solving any problem in any country. And as Eco Science Foundation, I think it is better to define a project for STI on renewable energy for eco-member states. This project can be a start point to start to be resulted in a deep collaboration between ECO members in technology and in engineering. And this project can be a start right now, not even 3 to 6 months later. Next slide. Before closing my speech, I want to recite a poem by the brilliant mind of the Islamic world, Allama Ballahui. In a poem, start by پس چه باید کرد ای اقوام شهر باز روشن می شود ایام شهر. O Orientals, what should we do to recuperate the glorious days of Orients? It terminates with this line. وای از آن موج دریا که موجش کم تپید گوهر خود را ز غواصان خرید. A bloodless sea will beg its own pearls from others. Thank you.
Thank you so much, Professor Bashadi. And now let's welcome Professor Sayyid Ali personally, and so that he can share his wisdom on it. And just a question, since he has worked a lot in intelligent systems and design, and we were talking about energy efficiency, so today it's not just about energy, but much more about intelligent systems that anticipate demand, cut wastage, and optimize supply. So where do you think the biggest opportunity for ECO countries would be for having that intelligent efficiency?
Thank you very much. Bismillah ar-Rahman ar-Rahim. Ladies and gentlemen, Assalamu alaikum, and thanks again to the organizing team. My answer to this question is sharing experiences. And my speech is just to talk about sharing some experiences. When we're talking about the energy and in the future and the current challenges. Sometimes we look at the global to produce energy, how to transfer and others. But my speech is to look around us and try to do something with saving energy, just around us. So about 10 years ago, I was the first deputy of the rector of Shiraz University. Then in that time, we had some energy problem in the university. This is the study that we did based on that issue that we had, and I just tried to share that one. Well, we all know about the continuous increase in energy consumption, and also my emphasis is despite awareness of the crisis, practical and efficient strategies have not yet been fully implemented to improve the current situation in Iran and many other countries. What I want to say here is not just in energy sector. I have had several industrial projects with petrochemical engineering industries, with gas industries, with power plant industries, and in the world, most of the automation systems are not fine-tuned. More than 80% in the world are not fine-tuned. And with some simple tuning of them, you can increase the efficiency 10%, 15%. In Iran, it is more than 95% of the industry's automation system are not fine-tuned. So with simple tuning or retuning, you can do a lot. This is in the energy side. I'm focusing on energy management in our administration of building. Here is Shiraz University administration of building, about 15,000 square meters, two buildings, one about 20 years old, one about 8 years old. So almost modern building and with modern facilities. The study suggested improvement include smart thermostat replacing AC motors and using automated control and energy label for the system. So we are talking about the experience that we had and the study we did on the energy management of this building. For myself, when I was thinking of this building with the huge powerhouse and the heating system, I thought that maybe the heating system spend more than 60 or 70% of the energy of this building, its administration of building. But if you look at the lighting, it's 90%, heating 48%, office equipment, the computers, printers, scanners are 22%, even more than lighting, and the others are 11%. So that brought us to take care of this office equipment and the lighting, and also to the heating system. We look at the energy consumption of each part. For example, booster motors, they are the kilowatt hours per year. These are the numbers generally to give you some figures of the differences and the energy consumption. Sorry about this image. So energy consumption of the motors and motor houses, I showed you there. So what we did, what we experienced on managing the insulation, the controls, the motors, and the inverter, using inverter and electrical valves and intelligent control could brought us to the reduction in total consumption to the percentage that you will see. Insulation about 12%, intelligent control 32%, and using inverters and electric valves 16%. These two together almost 50% of energy consumption. So here is also about the consumption of various office equipment, from computers, printers, copiers, UPS, scanners, and other, an elevator, water purifier, and different things. So you will see the consumption and the quantity. And so breakdown of office equipment energy consumption, you will see here the computers that we are using a lot is the largest, about 70% of the energy consumption of this office equipment. 70% of office equipment. So, sorry for about this first one. So, some suggestions and strategies for energy saving in middle term and long term. Office equipment, some simple things, simple suggestions. Turning off computers, copiers, and other equipment, and turning off the main power when not used. Ensure that administrative devices are turned off. So you will do this, and most people know that. Use computer and office equipment such as printer when needed, or use energy saving modes for a sleep quiet mode for the computers and other devices. I return to the fact that 70% of those office equipment were computer consumptions. So with just simple tuning, or if you have one technical staff to just go around the offices, just check and do a small changes in the tuning, you will get great saving. Energy saving modes such as the sleep something, do not forget that. Activating these modes can reduce energy consumption but up to 70% for computers. Computers 70% from whole, 70% of computers with this tuning only. So for night period, absence from research, computer should be completely shut down in a sleep mode, energy consumption decrease, use computers operate to board and others. So other measures, improve the efficiency of electrical devices that we all usually do, like power stabilizer, use controller and devices with low energy consumption, utilize internal network systems, but with today's AI availability in all our systems, so you can easily ask advice. You see in the administration of building, there are standards for the proportion of energy consumption from each equipment or each sector of the building. Ask AI, these are our consumption based on what we have. What is the problem in our building? And then use intelligent tuning and intelligent setting beside of changing the lights or other. Use fast automation system. We improve some of the tuning of our powerhouse in our heating system, and we save up to 35% of the energy consumption of that big line of almost 50% of the whole consumption was heating system. But with good tuning, we came up to 35% better activity. Use suitable setting for copier and others, and also use the recycled paper. There are some simple experiences that we had, and I leave this presentation here so later on we can use it. This is part of a bigger paper that we wrote after we implemented this strategy. Just remember simple things in life. These proverbs are often the best, or first thing first, before going after building new power plants and solving that big problem. Let's save up to 20%, up to 20 or 25% of consumption with these experiences. And let's share experiences to have a better world. Thank you very much.
A round of applause for Professor Sayyid Ali Abdul. That was music to our ears. Let's move on to efficiency. Now let's welcome Mr. Kabir Razak, my dear friend and our host as well. And just for a question to you, first on e-mobility. If I were to leave Islamabad just after Juma prayers or our Friday prayers, and I get a top-notch electric vehicle today from Islamabad, all that one can buy, and we went on a route towards the EC origin. Do you think I'll be able to make it crossing through all corridors and capitals? What will be my bottlenecks in terms of policy, infrastructure, and all?
Having the liberty of please write them, please share that.
Consider yourself home.
Yeah, it's not. Can you write it?
Well, first of all, thank you very much to National Energy Efficiency Conservation Authority (NEECA) for this hosting this panel and all the esteemed panelists. Perhaps the best car today in the market with a 1,000-kilometer range, you would be stuck somewhere in the bottom. Yeah. If you try to go to Afghanistan, you'll be stuck. You might be able to cross Punjab and get to Balochistan, but where you cannot find the others. But we have studies that Turkey is quite well connected in terms of electric mobility. If you turn on the slides. So my topic is decarbonization of road transport sector and transitioning into electric mobility in the EC origin. So electric mobility is the next transition of the road transport sector. The first transition took place back in 150 years back when there was a shift from steam engines to fossil fuel powered vehicles, both in terms of the rail and the road. And I think this is the time where we are witnessing another industrial change at a scale that we have not seen before. And this is where electric mobility comes in. If you go to the next slide. So there are two main reasons why this shift is taking place. Number one is that we have achieved the technological advancement of the necessary, essential electrical and mechanical system that we are now able to move to that stage. The second is the climate change. So I'll look into the issues perspective. Both these aspects of either because of the climate change and climate mitigation, we need to move to decarbonization of transport and all other economic sectors as well. So if you look at this chart, in simple terms, what you see here is that we roughly emit about 50 billion tons of CO2 every year. And what the Paris Agreement says by 2100, we should be able to reduce them down to about zero. Yeah. Now, so right now we emit about 50 billion tons. If we want to achieve the 1.5 degrees Celsius target by 2100, we need to reduce it down. So we need to reduce these emissions in several economic sectors, and transport is the most important where we can achieve it.
And why transport is important? Because transport is the low-hanging fruit. It is the sector where we can reduce the transport emission in the most easiest possible way. In other sectors, for instance, steel decarbonization or chemical industry decarbonization, these are still those sectors that are very difficult to decarbonize, or aviation or shipping. But this is a sector that the technology is available. We have achieved the economies of scale, and it's now economically and technically possible to do that. Next slide. Right. So, I have a few slides, but I think this is the most important slide that we need to focus on. The success of electric mobility transition or the adoption that we have seen around the world and within the region, these are the four main pillars where we see or identifiers where we can see that the transition to electric mobility is taking place at a level that we can achieve. Number one is the policy. Any country, either we look into Europe, Norway, Germany, or Austria, or in the West, Canada or the US, or the China. China has been the leader. Almost half of the new electric vehicles globally that the China is injecting into the market. So the policy remains at the core pillar. So the policy determines any nation or economy, how do they strategize their targets and visions for transport, for decarbonized transport. So if there is strong policy incentives, if there is strong policy tools, either in terms of regulatory, finance, or in the form of public awareness, we see higher adoption of electric vehicles. Second is a battery. So why the shift is being very rapid in the recent years, because the battery cost, so the half of the cost of electric vehicle is battery cost. So the battery cost has come down significantly from about $1,000 10 years back to about $150 today. And the tipping point is if it reaches about $80 per kilowatt hour, the cost of an electric vehicle and internal combustion engine would coincide. So it would be cost competitive by that point. Till that time, like for instance, today's battery cost is about $200 per kilowatt hour. We need to reduce it down to 80 kilowatt hours to make it competitive with the internal combustion. Because of this differentiation, we need to provide any subsidies, and the policy make a greater role into this. The third important aspect is the charging infrastructure. This is both psychological and also technological. In majority of those affluent economies where they have dedicated garages, or they have detached houses for short-term visits. Now we have vehicles in the market with a range of about 1,000 kilometers in one go. Usually, you do not need to rely on for passenger vehicles. You do not need to rely on a robust charging infrastructure for short commute within 500 kilometers. But for commercial mobility, yes, we need robust, resilient infrastructure that is accessible and also cost effective. For supply chain, now this is another important area. For countries in the ECO region, there are 5 countries that produces or manufactures or assemble cars. Number one is Turkey. Turkey produces about 1.5 million vehicles in a year. After that, Uzbekistan. I think Uzbekistan produces about 250,000 cars. Iran about 1 million cars a year. Pakistan around 250,000 to 300,000. That's a production capacity, but it varies from how the economy is moving to various other factors, and also Kazakhstan. So these are the 5 countries that produces cars on their own. They have the potential and the capacity to transit to manufacturing and supply chain, and the biggest player in the market is China. Almost 90% of the refinement that takes place in the battery system. This is the the China holds that dominance of about 90%. So if you have for Pakistan's case, there is a lot of talk about that we need to move to EVs, but it would only be sustainable, cost competitive, and economically viable for us if we are able to produce and manufacture or assemble vehicles on the ground. Otherwise, if we rely on importing vehicles, the cost of importing vehicles would be as much as that we produce as we import the fuel. First of all, that's about $15 billion. So this is a snapshot of what what are the policy metrics of Afghanistan or the ECO member countries. We don't have data for Afghanistan. So we look at the EV policy framework from 5 different indicators: national targets, mandated purchase subsidies, import duties, tax subsidies, and preferential law. So at the moment, Turkey seems to be green in all these areas. You see, they have a mandated target, they have purchase subsidies, they have import duty waivers, they have tax subsidies as well, and they also provide preferential laws. For Pakistan, we have a very robust target, national targets by 2030 and 2050, but we don't have purchase subsidies. Again, on the import duty waivers, all Central Asian economies, be it Kazakhstan, Tajikistan, Kyrgyz Republic, or Azerbaijan, they have waived their import duties. Not in that case. And also, we don't have preferential laws. So, I would suggest that perhaps I don't have time to explain each one of those. You go and study there. The greens are those areas that we are doing really good, and light greens are that we need to even work more, but the red ones are one that we need to work urgently. This is about the trade of ECO region of vehicles from China to the ECO member countries or from the Europe. I think here the only outlier is Pakistan. Majority of ECO region imports are so the red bars that you see on the horizontal bars, the red is China. So Mongolia, Tajikistan, Kazakhstan, Pakistan. So almost all Central Asian economies, over 70% of their vehicles, electric vehicles, come from China. Only Pakistan then, because we have legacy import trades with Europe, particularly Japan, and also Britain. This is very important. So, for instance, one of the few countries like Turkmenistan, Uzbekistan. So, what you see on your right, these are ICE emissions. The red line is ICE emissions. So, if you drive any internal combustion engine, you would emit 115 grams of CO2. But the grid in Turkmenistan, Uzbekistan is so dirty that the power supplies come from coal that it won't make any difference if you drive electric vehicle or internal combustion engine because the grid is so dirty. And again, the running cost is an important metric. So Pakistan, we have the highest electricity rate for domestic but also commercial. So what you see is the green is a $15 per kilowatt hour, and the red bars you see it's the cost for internal combustion engine, and the green bars you see is the electric vehicle cost to drive. So for Pakistan specific, we don't have much